Assalamu alaikum students. Today we will discuss the MCQs of D and F block elements. The first MCQ is, which set of the element is transition metal? Here iron, chromium, gold and nickel are the transition elements, so option B is correct here. Look here, lead and stainless and carbon, they are present in P block, which means that they are not transition. Here the lead and stainless and acetylene, they are present in P block, and aluminium is present in P block. So the set of element which is transition is option B. Transition elements have dash orbital partially filled. We know that transition metals have D and F orbital are partially filled. Okay. Now more specifically, in case of D block, here option A is correct. Okay. In case of D block, the Ns and N-1d orbital are partially filled, while in case of F block, N-2 F, N-1d and Ns orbitals are partially filled. Okay, so look at the option A, this one option is correct. Look at the B option, Nd and Nf, so this one is incorrect. Okay, look at the C, N-d, but here it is Np, this one is also incorrect. Okay, so for D orbital, the partially filled orbitals are Ns and N-1d. For F block, the partially filled orbital are N-2f, N-1d and Ns. Here option A is correct. In first transition series, 3d orbitals are filling. They occur in. Now we know that first transition series generally we write N-1d. Okay, where N is the period which is 4 minus 1d, so it will give 3d. Okay, so the 3d orbitals are present in fourth period of the periodic table. The oxidation states of transition elements is due to the involvement of both D and S electron. Okay, now we know that the D and S electron has comparable energy, which means that the difference between the energy is very much less. Okay, that's why the variable number of electrons can take part in the bond formation process. So they have variable valencies and variable oxidation states. The lanthanide series follow lanthanum. This series is included in the 6th period. Okay, lanthanide series is included in 6th period and actinide series is included in the 7th period. The third transition series belong to which period of the periodic table? Now the first transition series belong to the 4th period. Okay, first transition series belong to 4th period, second transition series belong to 5th period, and the third transition series belong to the 6th period. Okay, third transition series belong to 6th period of the periodic table. Look at here, this is the periodic table, and this series is called first transition series, which belong to 4th period. This one is called second transition series, which belong to 5th period, and this one is third transition series, which belong to 6th period, and this one is fourth transition series, which belong to 2nd period. And look at here, this one is lanthanide. Okay, and this lanthanide is come from here. Okay, and this is from 6th period, and this one is called actinide, and this actinide is here, it is derived from here. Okay, and it belongs to 7th period. So the third transition series belong to 6th period of the periodic table. Which of the following is the correct electronic configuration of chromium? Atomic number is 24. Now we know that chromium belong to 4th period. Okay, and 4th period starts from 19 and it ends at 36. Okay, now when it starts from 19, it means that 1s2, 2s2, 2p6, 3s2 and 3p6, which is equal to 18. It will be common in all the 4th period. Okay, in all the elements of 4th period. So instead of writing this, okay, we simply write the argon, because the atomic number of argon is also 18. Okay, now we here look at its atomic number is 24, so we will write 3d4, 4s2 and 3d4. Okay, now we know that first we fill the S and after that we fill the D. Okay, D orbital. Now look at here, it is 4s2 and 3d4, and we know that the orbital which is half filled is stable as compared to partially filled. Okay, now look, it is partially filled. We have to make this orbital is stable. So in order to make this orbital stable, this D, here the one electron comes here. Okay, from S orbital, one electron come to the D orbital. Okay, now look, it is half filled. which means that now it is more stable. Okay, so it will become 4s1 and 3d5. Now this is the stable electronic configuration of chromium. So here option D is correct. Option B is correct. Okay, 3d5 and 4s1. The paramagnetic nature of a substance depends upon the number of unpaired electrons. Option C is correct. Okay, we know that an electron spins in its own axis. Okay, let's suppose this is an electron and it spins on its own axis. Okay, now we know that when a charged particle moves, okay, when a charged particle start moving, what happens? The magnetic field is produced around it. Okay, so it means that when the electron is spinning, this electron is producing a magnetic field around itself. Okay, and we can say that the electrons are the tiny magnets. Okay, that's why the paramagnetic nature of the substance depends upon the number of unpaired electrons. With the increase in number of unpaired electrons, paramagnetism increases. Okay, option A is correct. Like when we increase the unpaired electron, it means that we are increasing the number of tiny magnets. Okay, because electrons serve as a tiny magnet. That's why the paramagnetism will also increase. Select the element which is not ferromagnetic. Now let me tell you that in compound form, many transition elements can serve as ferromagnetic element. Okay, in the form of compound, they can serve as ferromagnetic. But in case of element, only iron, cobalt and nickel will be ferromagnetic in nature in case of element. Okay, again, in the form of element, only iron, cobalt and nickel will be ferromagnetic. So select the element which is not ferromagnetic. The not ferromagnetic is antimony. Okay, SB. And another thing is that this antimony is not the transition metal. Okay, it is p block element. So that's why this one is not ferromagnetic. Iron, cobalt, nickel show +2 most stable oxidation state because of the increasing nuclear charge pulls the d electron from bonding. Now we know that across a period the nuclear charge increases. Okay, let's suppose this is a nucleus. Okay, and let's suppose this is d orbital. Okay, and electrons are present, and this one is 4s, and here are the 2 electrons. Now when we go across the period, the nuclear charge increases and the electron also increases here in 3d orbital. Okay, so what will happen? Electron will only attract these nucleus will only attract these electron. Okay, and the nucleus will unable to attract the s electron because this d electron shields the s electron. That's why the nucleus will tightly attract this d orbital electron towards itself, and due to the shielding effect of these 2 electrons, this d orbital electron, the electron of s orbital will be free to take part in the bond formation process. That's why when the atom lost these 2 electrons, it will gain +2 oxidation state. Okay, now look at the MCQ. The iron, cobalt, nickel show +2 most stable oxidation state because the increasing nuclear charge pulls the d electron towards itself, and it prevents the d electron from bonding. Okay, that's why only the s orbital electron take part in the bond formation process, and thus it gain +2 charge. So here option B is correct. Most of the catalytic elements or their compounds belong to D block. Okay, this is because D block has the ability to form the intermediates compound, and also it has the ability to form the interstitial compound. Like in D block elements, the crystal lattices has small holes. Okay, and in these holes they absorb the reacting substance, and that's why they can easily be converted into product. Which one of the following will be a colorless complex? Now we know that the color of the transition metal is due to the DD transition. It means that, let's suppose this is d orbital 1, 2, 3 and 4. Now the electron when transferred from one orbital to another orbital, it means that DD transition occur in the transition metals, and what will happen? It will give colors. But look at the scandium +2. The d orbital has 0 electron, which means that no transition will occur between the electrons of d orbital. That's why the scandium will give colorless complex. The color of the transition metal complexes is due to the DD transition of the electron. The transition metal form complexes due to vacant d orbital. Here option C is correct, because in transition metals the d orbital is vacant and it has the ability to accept lone pair of electron from the other ligands. Okay, that's why when the other ligands donate the lone pair, and it accepts it, okay, because it has the vacant d orbital, and thus it forms complexes. Formation of colored solution is possible when the metal ion in the compound contain unpaired electron. Okay, when the compound has unpaired electron, like look, this is d orbital, okay, d subshell is here. So when it has unpaired electron, it can easily do transition from one orbital to another orbital, and it will give the colored solution. That's why here option B is correct. Brass is an alloy of copper and zinc. Option A. Complex compound in which the oxidation number of a metal is 0. Now look at here. We know that cyanide also have oxidation number. So look at here. Fluorine has oxidation number. Look at the C option, nickel carbonyl. Look, we know that this carbonyl is a neutral. Okay, when this is neutral, it means that oxidation state will be 0 for this, and in turn nickel will also have the oxidation number 0. Okay, and its IPAC name is tetracarbonyl nickel. Okay, tetracarbonyl nickel, and its oxidation state will be 0. Ethylene diamine is an example of bidentate ligand. Okay, look here, lone pair is present here and other lone pair is here, so it means that it will donate 2 lone pairs. Okay, so this is bidentate ligand. The coordination number of copper in, now look at here, we have to find the coordination number of copper in this complex. Now look at here, we know that ethylene diamine is the bidentate, okay, which means that it, and here look, ethylene diamine is 2, which means that it will give 4 lone pair. Okay, now look at here, chlorine has donated 1 electron, which means that the chlorine is monodentate. Okay, so and there are 2 chlorine atom, so 4 plus 2, which means that copper has coordination number of 6. Look, chlorine is monodentate and this one is bidentate, so 2 to 2s are 4 and 1 2s are 2, so it will give 6. Okay, coordination number of copper is 6. Which one is the formula of tetraamine chloronitro-platinum 4 sulfate? Now look at here, first of all, look, it is tetraamine. Now tetraamine is present in this one, also tetraamine, this one is also tetraamine, and this one is also. Now look, chloro, look at here, chlorine is not present, which means that this one is incorrect. Here dichloro, 2 chlorine is present, dichloro, and it is 1 chlorine, so it means that this one is also incorrect. Okay, now look at here, here is 1 chlorine and here is also 1 chlorine. Now next, nitro-platinum, nitro, look at here, there is 2 nitro and here is 1, so this one is dinitro and the required is only nitro, which means that this one is also incorrect. So the correct one is option D, tetraamine, chloro, nitro and platinum plus 4, platinum 4 sulfate. Look, we know that this one is -2, this one is +2. Okay, chlorine has -1. Okay, NO2 also have -1. Okay, and this one is neutral, so it will be 0. Now +2, so platinum plus -1 and -1 is equal to +2. Okay, so platinum is equal to +2, and bring this -1 will be -2, and bring this here, so it will be +2. So platinum is equal to +4. Okay, here the oxidation state of platinum is +4. Look, 4. So option D is correct. The IPAC name of this, now look here, ONO is called nitrato. Okay, look, pentaamine nitro, this one is also nitro, it means that these are incorrect. Let's see in these two. Okay, nitrito, and this one is also nitrito. Cobalt, here the oxidation state is 4 and here it is 3. Let's find the oxidation state. Look at here, oxidation state of nitrito is -1. Okay, and this one is neutral, so it will give 0. So cobalt plus -1 is equal to +2. Okay, look, this one is charged, so it will be +2, or cobalt is equal to, bring this -1 here, +2 plus 1, so it will be +3. Okay, oxidation state of cobalt is +3, so it means that this one is correct. Okay, option D is correct here. plus 3 cobalt 3 ion. The opaque name of this. So look at here, potassium is present in all tetra cyano. Now look at here, this one is cyanito and this one is also cyanito. Okay, so but here Cn represents cyano. Okay, so it means that these two is incorrect. Okay, now we have to find the correct one is in these two. Now look at here, this one is nickel and this one is nickelate 2 and 3. So let's find the oxidation state of nickel. Okay, so here K2 is here plus 2. Okay, and this one will be minus 2, and here we know that cyano is minus 1, so it will give minus 4. Now simply you have to find the oxidation state of nickel. Simply make this one plus. Okay, like plus 4, make this one plus and minus 2. Okay, so it will give plus 2 oxidation state. Okay, this one is the shortcut. Look here, this one is the shortcut. Okay, look at here, it is minus 4. Okay, simply take this one is positive plus and subtract minus 2 from it, you will get plus 2 is oxidation state directly. Okay, this one is the shortcut. So nickel has plus 2 oxidation state. Now it means that option B is correct here. Look, this one is 2 and this one is 3, so it means option B is correct. And look at here, nickel and nickelate, we know that when the coordination pair is negative, so we will take nickelate. Okay, so option B is correct. Oxidation state affect the nature of compounds. Compound of vanadium are ionic in dash oxidation state. Look, these are the oxidation state given for vanadium. Which one is ionic? Now we know that according to Vthen's rule, small charge will be ionic in nature. Okay, a cation having smaller positive charge, okay, will be ionic in nature. So option A is correct here. Plus 2 will be ionic in nature. A colourless compound of vanadium plus 5 gives blue vanadium plus 4, and then green vanadium plus 3, and finally violet vanadium plus 2. This is done when it is reacted with. Now look at here, from plus 5 to plus 4, then to plus 3, and then to plus 2. It means that vanadium plus 5 has gained electron. Okay, vanadium plus 5 has gained electron. It means that in vanadium reduction has occurred. Now this is done when it is reacted with reducing agent. Okay, let's suppose here is X substance. Okay, when this X substance is reducing agent, then what will happen? It will reduce the vanadium, it will give the electron to vanadium, and itself it will be oxidized, which means that itself it will lose electron and it will give electron to vanadium. So this is done when it is reacted with reducing agent. Various oxidation states compound of chromium can be used as reducing and oxidizing agent. The most common are, now look at here, what is reducing agent? Reducing agents are the substance which has the capacity to lose electron. Look, reducing agents are those substances which itself get oxidized but it reduce the other substance, which means that it lose electron and give electron to other substances. Now look, it is chromium plus 2, okay, and look, it is chromium plus 6. Now chromium has lost 6 electron here and it has lost 2 electron here. Now chromium plus 2 has the ability to lose some other electrons. Okay, and look, chromium plus 6 don't have any ability to lose other electrons. Okay, it has not any electrons for losing. Okay, instead it will only gain the electron. Now look at here, it has the capacity to lose, that's why it will act reducing agent, and it has the capacity to gain the electron. Okay, because it can only gain electron and it has not any other electrons to lose, that's why it has the capacity to gain the electron. It will act as oxidizing agent. Oxidizing agent are those which itself get reduced, which take the electron and it oxidize the other substances, which means that it makes the other substance to lose electron and it gains that electron. Okay, so here option A is correct. Look at the B option, chromium plus 6 reducing agent. This one is incorrect because chromium plus 6 cannot be reducing agent because it has not any electron for losing. Okay, chromium plus 2 oxidizing agent. This one is also incorrect because the stable oxidation state for chromium is plus 3. Okay, so it will lose the electron in order to make itself stable, that's why it cannot act as oxidizing agent. Potassium chromate, when dissolved in water form a yellow solution, potassium dichromate produces an orange solution. these colors come from the negative ions respectively. In solution, the ions are in equilibrium given below. Okay, the ions are given here. This dynamic equilibrium is sensitive to acidity and basicity. Now, addition of acid increases the orange color. Now look at here, when we increase the acid, okay, plus H plus ion, then what will happen? The reaction will goes to forward direction in order to come in equilibrium. Okay, so in this case the orange color will increases. Okay, and addition of base will increase the yellow color. Okay, when we add base in this side, so the reverse of the reaction will occur and it will increase the yellow color. So here option A is correct. Manganese, look, electronic configuration is given, exists in plus 7 plus 6 plus 5 plus 4 3 2 oxidation state. The stable oxidation state is due to, now look at here, plus 2 is the stable oxidation state. Now what is the reason? Let's suppose this manganese lost this electron, then what will be the electronic configuration? Will be 3d5. okay, and I have told you that the half orbital has greater stability as compared to the partially filled. Okay, now look at here, it will be like this. Now look, the D subshell is half filled. Okay, now this half filled will have greater stability, that's why plus 2 is the most stable oxidation state. Here option D is correct, half filled d orbital. If this manganese lost 3 electrons, then what will happen? This electron will also be lost. Okay, so after this it will not be stable. Okay, because the orbital will be partially filled. Okay, after losing this one, that's why we say that plus 2 is the most stable oxidation state, because after losing plus 2, what happened? The d orbital become half filled. Okay, the d orbital become half filled and its stability become greater. So option D is correct. KMnO4 acidified is used for the oxidation of alkene to glycols. During the reaction, the purple color of the solution changes to colorless. Okay, when glycols or alkene is reacted to the acidified KMnO4, then what happens? The purple color changes into colorless solution. The most stable form of iron is rough iron. This is because the number of carbon atoms are very less. The percentage of carbon atom are very less in rough iron. That's why it is the most pure form of iron. The richest iron ore is magnetite. Option A is correct here. Potassium dichromate acts as a strong oxidizing agent. Option A is correct here. Look, the oxidation state of chromium in potassium dichromate is plus 6. Okay, and I have told you that this plus 6 will act as oxidizing agent, and because it has the ability to gain the electron. Okay, it has the ability to gain the electron, that's why it will act as strong oxidizing agent. And here we know that plus 3 is the most stable state for the chromium. That's why this chromium will tend to attain the stable oxidation state. That's why it will act as oxidizing agent and gain the electron, and it will come to the lower oxidation state. This lower oxidation state may be plus 5, plus 4 or plus 3. Okay, so potassium dichromate will act as strong oxidizing agent. So this one was the last MCQ of D and F block element. If you have any problem in this MCQ, then write in the comment section. Allah Hafiz.